Okay, so hello everyone. Myself Venu, lecturer in mechanical engineering from Government Polytechnic Varangal. And, subject dealing is refrigeration and air conditioning. And today's video lecture goes on the refrigeration equipment. So far, if you observe my video classes, we have seen chapter-wise discussion is going on. We have seen the first topic, some basic fundamentals of refrigeration and some basic concepts on refrigeration, and next we have seen the other in the main topic of the air refrigeration, vapor compression refrigeration, vapor absorption refrigeration, and seen some subtopics regarding those main topics also. Okay, and in continuation of that, next we will discuss move into deeply into the discussion regarding the equipments which are used in the refrigeration. So here today lecture will goes on the refrigeration equipment. What are the main equipments which you are seen? Mostly we are concentrating in the vapor compression refrigeration system. Like we have seen some main components like compressor, condenser, expansion valve, evaporators. So in that we will see different types of them, and we will learn more about individual component and individual equipment and more. So we can learn we'll see what are the different types, what are the function of each and every equipment which are used in the refrigeration. So all the things can be learned in this today's lecture. So hope you can understood after the completion of this topic all the objectives which are there, we can fulfill that by going through this video session. So let us start the today's video session on refrigeration equipment. Completely it is a different a new chapter after the successful completion of the all other topics of a previous chapter which are seen in the last video classes. Okay, so right, so let us start with just the objectives directly. So here all told about the completion of the class, so you will get some information regarding all the equipments and what are the types, what are the importance of that particular equipment. Just we list out all them and list out all the types. We will discuss one or two equipment in this today's class. So here the regarding you can understood regarding the refrigeration equipment, and next we will focus on the some types, so the function of the compressors and some classification of the compressors. So we will cover these topics in today's video class. And coming to the refrigeration equipment, so here the various components needed for the successful working of a refrigeration unit are termed as refrigeration equipment. So regarding this statement, so what when the system has to work properly, it requires some the refrigeration equipment. Some equipments are required to give the refrigeration effect. So here the important components already you know all these things, just we list out them again. And here the important components in the refrigeration systems are the compressor. It's the main heart of the system. It has it will do the different function if it works properly, and the total system will work properly. Next, the condenser, expansion device, evaporator. So in the discussion of the system, we just focused on the what is the function of that particular the component like compressor, condenser, like that we have seen that. In this the starting of this this chapter will more concentrate how the compressor is working, what are the mechanical components involved in that, what is happening each and at each and every point, what is happening, how the refrigerant is entering, how the refrigerant is exiting, how the pressure is increased, how the temperature is increased, and what are the components used in the compressor, what are the mechanical components. So each and every thing, the functioning of each and every component can be seen in this this chapter. So these are the listed out important components in the refrigeration system. So today we will more concentrate on the compressor, the function of compressor. We will see some line diagram of that, and we will see the different types. In that we will discuss one or two types of compressors. So it is very quite interesting topic. Just if you look at the compressor, you know the function of a compressor, right? So what I have told, the first point regarding that is the heart of the, if you see that, you can read that statement. The heart of the vapor compression system is compressor, right? And here, uh, as already discussed in the previous, the differences between VCR and VAR system. Vapor compression system is more costlier than the vapor absorption system. Why? Because it contains the VCR system contains the compressor component, where it requires the lot of mechanical components in that, and it requires the electrical connections. So more costlier than the some vapor absorption system, where the compressor is absent in that case. So since it is driven by electric motor, so it is a compressor is a costlier component in the refrigeration system. Now if you see the location of the compressor in the system, in the VCR system, so it is located in between the, or it is connected in between the evaporator and condenser. So after the evaporator, it is connected, the compressor is connected, then next to the compressor the condenser is there. So this arrangement is made according to the flow of a refrigerant. Coming from the evaporator enters into the compressor, next from compressor it enters into the condenser. So the compressor is located in between the two components, that is evaporator and condenser, right? Next, that is regarding the compressor, where it is placed, and what is the compressor. We see here, you know, the main function of that. What it will first, I will discuss 3 points regarding in that, 3 main points of the functioning of the compressor. So what it will do is, with the help of a compressor, why it is named as the heart of the system, we will see that, just like a heart. So here, first thing is, the compressor sucks the vapor refrigerant from the evaporator. So whatever the vaporized form of the refrigerant present in the evaporator, so at the exit of the evaporator, the vapor refrigerant come outside and it enters into the compressor. So that how it is entering means the compressor sucking the refrigerant from the evaporator. So this is the first function of a compressor. Then next, after the completion of this first function, the next function of the compressor is, whatever the vapor refrigerant entered into the compressor, it compresses the refrigerant. Okay, the vapor refrigerant which is there, it get compressed in the refrigerant which is coming from the evaporator. Here it compresses the refrigerant. That is the second, you just remember that point, compresses the refrigerant in the compressor. What happens here, the pressure and temperature of a refrigerant is greater than the whatever the entry you have seen before entering into the compressor. And at the exit of the compressor, if you observe, the high pressures and temperatures can be obtained in the compressor, right? And here the next function of a compressor is, then it will pump out, you can use that word, it will sends the vapor refrigerant with very high pressure and with very high temperature to the condenser component. This is the third function. First function is sucking the refrigerant from the evaporator, second function is compressing the refrigerant, third function is pumping the refrigerant to the condenser component. That is 1, 2, 3. So 3 main functions it is doing by the compressor. So with the given pressure, the refrigerant will move into the next components, right? So what is the continuation? It delivers high pressure refrigerant to condenser, and it maintains the continuous flow of refrigerant through the refrigerating system. So these are the main functions of the compressor. 3 main functions what I have told. Please try to remember that 3 functions of refrigerant compressor. Just it pumps the refrigerant through the system and simultaneously establish 2 pressure levels. Okay, so this is regarding the main function of a compressor. Next we will discuss the types of a compressors depending on different functions. We will see that, but before that there are 2 main groups of compressors. So in that in that 2 groups, a subdivision of a compressor will take place. So what are the 2 main groups we will see here regarding the compressors? One is a positive displacement and another one is non-positive displacement compressors. So we will see in a statement what is a positive displacement compressors and what is non-positive displacement compressors. So in these 2 groups, if you observe, if you consider positive displacement compressors, here you can read this statement. They prevent undesired reversal of flow and compresses the fluid within the closed space. So why the name is given, I think you have understood that. So it prevents the reversal flow. Means whatever the refrigerant present in the system, it will not come back again into the whatever the main entry it is taking place. It will not again come back and enter into the other component. So it will completely restricts the reversal of flow, and whatever the fluid present in the space, it will get compressed. So that is a those are the positive displacement compressors. For example, you can take a simple example, that is reciprocating compressors. Okay, reciprocating compressor. Hope you know regarding this reciprocating compressor. You will get some idea when we use this term. Reciprocating means piston is moving inside a cylinder from from top dead center to bottom dead center. Okay, right, whenever it is moving. And other example like rotary compressors also. Okay, so those are the positive displacement compressors. Next, so non-positive displacement compressor means when they have no provision to prevent. It means to prevent the reversal of there is no provision. It means to prevent the reversal of the flow, and they are not providing anything there to prevent that reversal of the flow. Like they are provided with the rotating vanes. Some rotating vanes will be there. Vanes are present on the rotating member, so vanes get rotated. So due to this rotation of the vanes, whatever the fluid is there, it will takes the fluid, and due to the rotation, what happens, the high pressure is created, and it releases out with the high pressure due to the rotation of the vanes. Vanes in just like some blade type of structure with some curved surface, curved structure like that. So example, you can take it as a centrifugal compressors. So it is the best example for non-positive displacement compressor. And here these are the two main groups. Next, so depending on the different things, it means different factors can be taken here to classify the compressors. So we will see those factors. The first factor you can consider according to the method of compression. So how it is compressing. So depending on that method, they are divided into like a reciprocating compressors and rotary compressors. By rotational motion of that particular things or particular blades, the compression is happening, and the movement of a piston in a cylinder. Okay, the method of compression is different in these two cases, reciprocating and rotary compressors. And third one is a centrifugal compressors. We will see regarding examples under these cases, rotary compressors and centrifugal compressors. We will see that line diagrams, and you can understood what are the reciprocating, rotary and centrifugal compressors. A different centrifugal compressor in the sense we utilize the principle of centrifugal force in the compressor component. Utilize that, and sucking the refrigerant, compressing the refrigerant, and pumping out the refrigerant to the outside. So that is done with the help of all these things, reciprocating, rotary and centrifugal compression. Now according to the number of working strokes, so this will happen in the like reciprocating compressor. If you consider just like your like a 4-stroke and 2-stroke engines, where you can see the cylinder and piston and cylinder arrangements, where there is a single acting compressors. Means whenever the fluid acting on at one side of a piston, so it can be a single acting and a double acting, in the sense both sides of the piston is taking place. Here I can take according to the number of working strokes. There is the first one is single acting compressor, and second one is a double acting compressors. Okay. This is the second factor. Next, third factor is according to the number of stages. Like you can take it, single stage compressors and multi-stage compressors. Okay. The compression which happens in a single stage, you can take it as a single stage compressors, and multi-stage compressors means using a number of different stages to compress the to attain a particular pressure. So multi-stage compressors can be used here. So So according to number of stages, single stage and multi-stage compressors. This is another third factor. Next, according to the method of drive employed. So it means here method of drive in the sense, in some cases there is a direct connection. It means so on a single shaft electric motor is placed, and the compressor, the crankshaft is connected. Whenever the electric motor is rotated, the crankshaft will also makes the rotation. So there is a direct connection, or it is named as a direct drive compressors. If take the second case, in that the belt drive compressors means electric motor is placed separately, and the crankshaft and piston cylinder arrangements are placed separately. So to rotate the crankshaft, what are the shaft of the crank, so this electric motor shaft and crank shaft, so both are connected with the help of a belt. Those are the belt drive compressors. Next, take other factor according to the location of the prime mover. So prime mover in the sense, you take what are the main just to take the main equipment which is used to run the remaining mechanical components. Just like you take some electric motor, which acts like a powerhouse. So whenever the electric motor is running, so consider that as a prime mover. So according to the location, so where that electric motor is placed, regarding like that, like a semi-hermetic compressors and hermetic compressors, or you can take it as like open type of compressors. Open type in the sense, just like a belt drive compressors, one is placed at a different place. It means electric motor is at a different place, and all the mechanical components, compressor components, are at a different place. So like that. Semi hermetic in the sense, both are placed in the same place, but here hermetic in the sense, the sealing of a compressor will not is in a semi way. It means you can open that whenever some errors or some damages or some repairs are obtained in that, so you can easily open that. Just like bolt screw connection will be there, so you can easily open that and you can make the repair for that. So a small design modification will be different in case of semi hermetic and hermetic. Hermetic in the sense, it is a completely sealed compressor. Okay, in this the this whatever the refrigerant, whatever the crankshaft, all the things, directly this it will sits on directly on the electric motor shaft, and the total compressor is a sealed unit. Okay, whenever the repair is obtained, whenever there is a repair, so it is very difficult. We have to cut the section, and we have to go for the repair, and it is a very compact one, hermetic compressors. So depending on location of like electric motor or whatever it may be, depending how we are, where at what place we are placing, so depending on that condition we are taken like that, like open type compressors, semi hermetic compressors, hermetic compressors. Hermetic in the sense is like a seal, complete sealed compressors. Right. Okay. Hope you have understood the classification of a compressors. Seen the different depending on according different factors, according to compression, according to number of strokes, according to number of stages. So different factors we are seen on, regarding in that we are seeing the different sub classifications. Two main groups of classification of compressors are two things. What is that? Two groups we have seen. They are very important. One is a positive, and other one is a just like a non-positive displacement compressors. So here the reciprocating compressor will falls under the category of falls under the group of that positive displacement one. Okay, positive displacement. So here the why it is named as positive displacement, the walls which are provided in these reciprocating compressors, so will not allow the reversal flow of a whatever the fluid which is compressing in the system, it will not flow back again to the different components. It will not flow back, reversal flow will not be there in this. So it is a positive type of compressor. So you can observe the diagram of this reciprocating compressor. So what happening, you can observe the diagram. Just observe the components involved in this, so you know well regarding what are the components present in the compressor. Okay. correct. So in this diagram of a reciprocating compressor, the main components just we list out here. So two diagrams are given of the same just the first diagram is indicating the piston moving down, the air flows into the cylinder. You can see the inlet valve is opened here. So through inlet valve the refrigerant is entering, vapor refrigerant is entering, the piston is moving to the downwards. So this is the diagram, and arrow indication to the downwards. And if you observe the second diagram, consider that piston is moving to the top, the compression is starting, piston moving up, air flows into receiver at a desired pressure through discharge valve. So here this what it is explaining here, piston is moving upwards, so compression will take place here, but compressed air is will evacuate through the discharge valve. Here the discharge valve is open, inlet valve is get closed here, inlet valve is get closed here. So this is the second diagram. So observe the components present here. The main valves involved in these are inlet valve and exhaust valve, or sorry, inlet valve and discharge valve. Consider second one is the discharge valve, and inlet of vapor refrigerant is inlet valve. And you can see the vertical component of that is a cylinder, and in the cylinder you can see piston is there. To the piston connecting rod is connected here. You can see the cross section, it may be a different cross sections can be used here of a connecting rod, and to the connecting rod crank is connected here, and crank is placed on a crankshaft. You can see at the center here there is a crankshaft, so which is connected to a electric motor shaft. So whenever the shaft, electric motor shaft is rotated, and the crankshaft will also get rotated. So these are the main components: two valves, inlet valve, discharge valve, and cylinder, piston, connecting rod, crank, and crankshaft. So there is a pin connected here between the connecting rod and crank, and pin connecting the piston and connecting rod. So two pins are used here. So this is regarding the components present in the reciprocating compressor. Next, just see the construction details. So here the reciprocating compressor consists of a cylinder and a piston, with piston connecting to a rotating shaft by connecting rod and crank. There is a rotating shaft at the center. Okay. Next, the valve permits the refrigerant fluid to flow in and out of the cylinder. So one it will use the inlet, and other one is the outlet, the cylinder. The piston reciprocates in the cylinder, and the distance moved by the piston between dead centers is called stroke. Okay. And next, volume displaced. So whatever the piston movement moved from one dead center to other dead center, so the complete volume occupied during the movement of the piston, volume displaced, is called swept volume. The minimum clearance when the piston is at the end of the compression. So when end of compression, it means the piston is moving at the top, so some minimum clearance of the piston is there at the end of the compression stroke, so it is called the clearance volume. Right, so remember these points. The volume displaced is called swept volume, and the minimum clearance when the piston is at the end of the compression stroke is called clearance volume. So here a small volume is present at the top, you can take it as a clearance volume when it reaches the compression stroke at the end. So total volume displaced is taken as swept volume. So coming to the working here, so when the piston from the top, it will move to the downwards, so the pressure in the cylinder, so here remember this one point, the pressure in the cylinder is less than the atmospheric pressure. It means to suck the refrigerant from the evaporator, so must and should in the compressor it maintains the pressure less than the atmospheric pressure. So just like a vacuum is created inside that, so it can suck the refrigerant which is present in the pipeline at the from the evaporator pipeline. So during this, what happens, due to less less pressure created, less than the atmospheric pressure is created, the inlet valve itself will get opens due to suction. Inlet valve is open, and now the refrigerant will get inlet through the inlet through the inlet valve. Now inlet valve opens, refrigerant comes and enters into the whatever the space provided in the cylinder. Right, now we'll see the next process. Here what we have discussed, the inlet valve opens and refrigerant vapors and flows into the cylinder. During this, what happens now, uh, whenever it is entering, so during the return stroke the piston will come to the downwards. During the return stroke, here the inlet valve closes when the pressure is just above the atmospheric pressure. Again the same thing here. What happens here, so during the return stroke, what happens here, the pressure will act on the top of the inlet valve. So suction will take place, and the pressure is inbuilding in the cylinder, the refrigerant is inbuilding in the cylinder part, so it will come downward, completely downward. So during the return stroke of the, it means when the piston is moving to the upwards, what happens here, the pressure is inbuilding in the cylinder, and pressure, it always acts on the top of the inlet valve, so inlet valve get closes. It means the pressure is just above the atmospheric pressure, inlet valve get closes. So remember that point. Next, here the pressure of the refrigerant steadily increases. So how the pressure is increasing here, the piston is moving to the top, piston is moving upwards, and the refrigerant pressure increases steadily. The discharge valve opens. So due to pressure increasing here, whatever the discharge valve is there, through the bottom the pressure increases, and it will try to push the discharge valve upwards, and slightly it get opened. Due to this pressure, the whatever the compressed refrigerant is there, it will pass through the delivery line to the discharge line. So here compression is taking place when the piston is moving up to the top dead center. Now at the end of the upward stroke, a small volume of refrigerant vapor. So here we have told that volume can be taken as a clearance volume. So in the clearance volume, a small amount of refrigerant is present, vapor refrigerant, which is at high pressure, so that will present in the clearance volume. Now as the piston moves downwards on the next stroke, so small amount is present. So whenever, again, what is the next thing, the piston will come to the downward on the next stroke. So this vapor get expanded again. Compression, the volume reduces, and clearance volume at the top, the refrigerant remains in a smaller quantity but with high pressure. So whenever the piston come to the downwards again, the volume is getting expanded, the refrigerant get expands, volume is more and higher. Again the pressure falls that below the atmospheric pressure, it's below the atmospheric pressure. Next, what happens, the same case again repeats. Due to lower than the atmospheric pressure, the inlet valve opens and the refrigerant will flow into the cylinder. Okay, again the same, the cycle is repeated again and again. Here the crank rotation is taking place like 180 degrees and 180 degrees. Due to this rotation to happen, the strokes like that, the suction and compression is taking place here in the compressor part. So this is how the refrigerant is entering, and how the refrigerant is delivering at one inlet and at outlet other valve. This is how the cycle is repeated, how the refrigerant is compressing here, and here the electric motor has to run continuously to make the component, the rotation of the crank continuously. It will passes the motion to the connecting rod, and the same thing it passes through the cylinder, the piston. The piston movement will take place in the cylinder from top dead center to the bottom dead center. Right, this is how the cycle is repeated and how this reciprocating compressor is working. Right, now just we are discussing regarding this. The most commonly used the refrigerants in this reciprocating compressor are the freon groups like R12, R22, R134A. These are the freon groups of refrigerants. Depending on the usage and the properties, depending on the application, you can use the different types of refrigerants. Most commonly used refrigerants are that R12, R22, R134A. So tetrafluoroethane, and the chemical name will be like dichloro, difluoromethane. So the methane groups, the freon groups, okay. Next, we'll discuss the one regarding the sub classification. We'll discuss regarding one type, that is a hermetic reciprocating compressor. As I already told, that is a completely sealed compressor. Just we have the line diagram regarding that. You can see the line diagram, so you can observe all the components for a while. So how to identify that is a hermetic compressor means, so it is a completely sealed unit. So in the unit itself, it contains the electric motor, and the electric motor shaft is directly coupled to the cylinder. Whatever the crankshaft is there, it is directly coupled to that, and cylinder, piston components, or valves, inlet and exhaust valves, so all will be placed in a single unit. So you can observe at the top there is a motor, and the shaft is connected to the crank here. So crank gets rotated and it connected to the piston and the cylinder arrangement. There are suction valves and discharge valves are present. So it is and lubricating oil is also present at the bottom to receive the heat generated by the electric motor here. So all the things are completely placed in a single unit. This is our completely sealed unit. So whenever some repairs are obtained here, so you have to cut the section and go for the repair purpose. So design is very complicated in this case. Now if you see, it is a direct driven unit. We have seen that there are two driven units. One is open drive, belt drive system, and direct driven units. So direct driven unit in which compressor and motor are unmounted, are mounted on one shaft. They are both of them are mounted, compressor and electric motor mounted on a single shaft, and are totally sealed from atmosphere. It is not exposed to any other pressures, so it is completely sealed as a one unit. And if you observe, whatever the connections making to this hermetic reciprocating compressor, those are only, one is the suction and discharge. That is there are outlet openings for that. One suction has to happen, discharge has to happen, and electrical terminals will be there. Electrical terminals to make the electric connection to the electric motor. So these are the only connections at the outside of this hermetic compressor, and remaining all things are get closed. So this arrangement eliminates the necessity of seal and consequently prevent refrigerant leakages. So it acts like a single unit, complete sealing is there, so no leakages will take place in this, right? So no other seals can be seen there. It is act like a single unit completely. Low pressure refrigerant vapor from the evaporator that enters causing through a suction line. So through suction line, the refrigerant which is coming with low pressure from the evaporator enters through the suction line here. And next, a cylinder is a horizontal, and you can see here at the bottom portion you can see there is a cylinder along with the piston, which is placed like a horizontal manner. And if you observe the crankshaft, it is a vertical which is connected to the motor shaft, coupled to motor shaft. The rotor of the electric motor is press fitted onto this shaft. You can see there is an electric rotor which is fitted to the shaft, and stator is formally secured within the casing. So it is placed at the sides, you can see here. So it is tightly secured at the sides. The stator and the rotors will be there here at the top of the casing, you can see here. Now the motor windings are directly exposed to the cool refrigerant vapor. So whatever the vapors entering into the compressor here, so here it is getting exposed to the refrigerant vapor, cool refrigerant vapor, and here automatically the cooling will take place with the help of this refrigerant vapors, so which enters and is drawn into the compressor. After making contact here, and that refrigerant can rotated or moved into the compressor component. So after compression, the vapor is discharged into a muffler, from where a tube conveys the high pressure vapor to a condenser. So there is a connection where after compression that it enters into a tube. So through the tube it passes through the next component, that is to a condenser. So the high pressure refrigerant vapor, it enters into a condenser through a separate connection will be there. So this is regarding the hermetic compressor. Next, coming to the advantages, if you see, a lot of advantages can be seen by using this hermetic compressor. So why they are mostly used, one, compared with other compressor like open type and semi hermetic, more the advantages are there in the hermetic compressor, right? So like a lot of noise can be reduced if you place electric motor or a compressor components at the different cases. They may are using the belt drive system, produces a lot of components involved in that, and produces more the noise. But whereas in the hermetic compressor, it reduces the operating noise as it is placed in a next one is here the complete prevention of leakage will take place. So it is a completely sealed compressor, so the leakage of the chance of leakages are very less in this case. And due to the design is very complicated and very congested in this, so a compact less space compressor can be obtained here. So it occupies less space and it is very compact here. Next, the further lubrication is simplified since both the units operate in a sealed space with the lubricating oil. So lubricating oil is also provided in that particular space is provided for that. And effective cooling of motor windings. Lubricating oil is present, uh, and also uh, the refrigerant vapor is making contact with the windings. So here the due to low temperatures, both the lubricating oil gets cooled and the motor windings will also get cooled. So effective cooling will take place here in this hermetic type of compressors. So these are a lot of advantages of a hermetic compressor, whereas disadvantages already discussed. The disadvantage main disadvantage is, so inner parts are inaccessible for repairs. So what I have to do, whatever the welded joints are there, complete sealed joint, so that have to broken for repairs. So this is one disadvantage. And this also I discussed, it is a design is very complicated in this case. So you will get one disadvantage in this, it's a complicated, but if you do that complicated design you will get very compact in size. It means less size of a compressor can be obtained. So complicated design, it is initially it is a disadvantage. Right. And another problem is whenever some moisture is present in the refrigerant vapor, so they may damage the wiring. Why? Because it is making contact with that to cool the winding there. And it may also damages the mechanical components. It may get corroded for longer usage. So must and should moisture which is present in the refrigerant vapor has to get removed, so that some safety devices can be used for removing the moisture content there. So these are the some advantages, disadvantages. And coming to the application part, so these compressors are employed in we can use in refrigerators or different freezers or in air conditioners, residential air conditioners. So in lot of applications are there regarding the hermetic compressors. It's mostly used nowadays. We are using mostly the hermetic type of compressors, a completely sealed unit of a compressor, so where it can be used for longer years. So that's the reason they are giving some warranty for a compressor about 10 years like that. If you observe in the if you purchase a new refrigerator or a new air conditioner, you can see the compressor warranty like that. That used, whatever the compressor used in that application is hermetic compressor. So about 10 years warranty they are providing nowadays. This is regarding the applications of hermetic compressor. Okay, so these are the topics covered in this today's video lesson, that is regarding what are the components, refrigeration equipments. In that we have started that first component, that is regarding the compressor. In that we have seen the subgroups, two subgroups, positive displacement and non-positive displacement. Next, the subclassifications depending on the different factors we have seen. In that we have explained one first example, that is reciprocating compressors. And next we have seen one subtype example, that is hermetic compressor. Okay. The next classes we will further proceed to the different cases. So before this we solve this quiz part. Reciprocating compressor is a dash type of compressor. So under what category we have seen, under what group we have seen? It is a positive displacement, right? It is a positive displacement. And on second option is non-positive displacement. No, it is wrong. And third, none of the above. And the answer is, it is a positive displacement compressor. The answer is right. Next, reciprocating compressor is the first one, positive displacement type, negative displacement, non-positive, and none. Answer again the same thing, it's a positive displacement. compressor type. Okay, a unit in which compressor and motor are mounted on a same shaft and sealed in from atmosphere and away from the atmosphere is a single unit. Compressor and electric motor, whenever it is placed on the same case, what thing you have to take. So it is a, when we have the options here, open type, hermetic, semi hermetic, and none of the above. So in which case both of them placed in the same case and sealed away from the atmosphere, it means it is a hermetic type of compressor. The answer you can note it down. It's a hermetic type. Open type and already I have discussed what is open type. Both are placed in separate places connected with the help of a belt drive system. Whereas semi-hermetic means here also the compressor and motor are placed in the same shaft, but it is not a completely sealed one. They are semi-sealed, complete made with some bolt and nut arrangement, so we can open that. A lot of vibrations will be created with the help of the semi-hermetic compressors. So completely sealed compressor is a hermetic type, and here the compressor and motor mounted on the same shaft. This is the answer. Remember those three cases. Okay, so this is regarding this today's video lesson. Hope you have understood the refrigeration equipments what are presented, main components we are discussing in this chapter, and we will mostly focus on all the objectives what we have seen earlier. So just to summarize, I think hope you have understood all the topics regarding this. That is regarding the function of a compressor, and some classifications of compressors, construction details of reciprocating compressors, and working principle of reciprocating compressor, hermetic compressor also. You have seen the line diagram, what are the advantages, what are the disadvantages, what is the applications. So all the things we have seen regarding this in this today's class, and we solved some quiz questions. Hope you have understood that, and you can solve that very easily. And I just note it down the frequently asked questions in this. So the first question is, what is a compressor, and list out various functions of the compressors. How many functions we have seen? Mainly the three functions or the main functions of the compressors. Okay, and you can just, what is a compressor, you can write in a statement. It's a very simple question. Next, classification of compressor. Just you have to list out depending on the according to the different factors what you have seen, depending on the compression, a lot of factors we are seeing. So like that you have to write all the classification of compressors, right? Next question, so draw a sketch of construction details and working principle of reciprocating compressor. So this is also a very important question. So all these first three are very important or frequently asked questions. This is also very important. Construction and working of hermetically sealed compressor with a neat sketch. Okay, so these are the few frequently asked questions regarding the topic what we have discussed till now, and hope you have understood, covered all the things in this video lesson, what the objects we have seen in the starting of the class. We have achieved that objects, and we have summarized all the things, and seen some frequently asked questions. So, it's very important, kindly note that. And if you understood this today's video lesson, and in the next video lesson we will see the continuation of these topics. It means we will see like a different topics, we will see some rotary compressors, we will see some centrifugal compressors, and next further we will see the condensers, the types of condensers. So we will see the all the topics which are limited, so time bound, what we have taken here regarding the 15-minute session. We will complete all the things in that in every video lesson. So hope you understood. So thank you for listening to this topic. Thank you.